All right, guys, sorry we got cut off again, but that's okay. We'll make all of these videos linked together so that way you can watch them in shorter clips. So again, we're all navigating new waters, and that includes me importing, exporting, downloading, figure out how to expand iCloud storage and delete off of it. It has been absolutely crazy. All right, so finishing this problem, where we left off, we need our kilojoules over moles. We've got joules, so we need to convert that to kilojoules. So how do we do that? Kilo, we've been using it for a very long time. 1 kilojoule is 1,000 joules. Kilo means 10 to the third, or 1,000. So we're dividing that by 1,000. So when we plug everything in up here, we should have a positive, which is very important, 7.406 kilojoules all over our moles that we got earlier. And then we can go ahead and divide that out. So I'm getting about 34.9. And our units are kilojoules over moles. Okay? And of course, notice this is really positive. What does that positive value tell you? This process right here being positive, this is endothermic. Our solution process is endothermic, and we know that because we got a positive value here. It is not exothermic. The solution in the calorimeter released heat, that means it took potassium nitrate energy. It had to absorb that in order to dissolve. Okay? So you have your own problem to work on at home. So feel free to contact me if you want to check your answer. You can show me your work. That would be awesome. It's bringing back some old pieces of information here. You're going to be having volume of a solution and density of solution. We used that way back in chapter 1. Okay, so volume times density, that's going to give you your mass of your solution. They also gave you the specific heat capacity of your solution. You also have your change in temperature of your solution. All those solution pieces of information should be over here. And then, of course, the only thing we know about the zinc reacting in the problem is its mass. And then, of course, we're solving for the enthalpy of that zinc reacting, just like we did in the previous process. So you're not going to have a lot of information over here. You're going to have a whole lot over here. And what you need to think about is if they gave you the specific heat capacity of the solution, which equation are you going to be using? Is it the one with the big C for heat capacity, or is it the one with little c, which is specific heat capacity? So in this video, we are going to work this problem together right here. We've got to create our own columns. So this problem, if you take a chance to read it, is talking about us dissolving potassium carbonate. So we've got to know our nomenclature, and we are dissolving it. That is our solution process. Okay, so that's one column. And then, of course, we've got the solution in the calorimeter. Okay, so I'm going to have 2 columns of information, and you should too. So it says 3.55 grams of potassium carbonate was dissolved in 75 grams of water in a cup calorimeter. This is different than the previous problem that we did, where it gave us the mass of the solution, or it talked about, not the mass, but it talked about the heat capacity of the solution. Water is not a solution. A solution is formed by dissolving something like a salt into water to make salt water, which is a solution. So we do have our mass of potassium carbonate. Okay. And we have our mass of our water. We need to label these things here. This is 75 grams. And again, this is water. Remember, this is very important. Water is not the solution. Okay? A solution is formed by dissolving something into water for an aqueous solution, or solute, and then our solvent is water. So keep that one in mind. It gave us the temperature change of our solution. So we have our initial temperature of 25 degrees Celsius and our final temperature of 17 degrees Celsius. Okay? And they said calculate the enthalpy for the solution process. The process is the act of dissolving the potassium carbonate. So we're trying to find our kilojoules over our moles over here. Okay? So once again, very easy to find our moles of potassium carbonate. We have 3.55 grams. Now, a lot of people like to add this to water over here. We're not dissolving water. We're dissolving the potassium carbonate into water. So we should just be working with our mass of potassium carbonate right here. So adding up our molar mass from the periodic table, it's about 138.205 grams per 1 mole. So that'll give you your moles of potassium carbonate. Okay, so let's go ahead and do that. Okay, so that's giving us about, assuming if I did it right, and anytime I make an error, make sure you guys call me on it. This is 0.0257 moles. Sorry about that. So 0.0257 moles of our potassium carbonate. So we've got that done right there, which is great. Okay, so they also said assume the specific heat of the solution to be the same as pure water. So we've got our little c of the solution. They said is the same as water, so we're going to say 4.18 joules over grams times degrees C. Okay, so we've got that right there. Now, the only problem is we have the mass of the water, not the mass of the solution. So how are we going to get the mass of our solution? Well, a solution's made by dissolving the potassium carbonate. So we've got to add those two masses together, our potassium carbonate and then our water. So now we have 78.55 grams of our solution. Okay. Now we're ready to do the problem. We have all of our variables here for our MCAT equation. So the Q for the solution, again, we are taking the time to label what our Q is. Don't just write Q and M. Who is it for? So we have our mass of our solution. We have our specific heat of our solution. And then we have our change in temperature. Remember, it's final minus initial, so 17 minus 25. Okay, notice that's going to give us a negative change in temperature. So the Q for our solution is going to be negative, and let me go ahead and multiply that out, and you should be doing that at home along with me. So negative 2,626.712, and that is joules. So now, just like the other problem, they want to know what is the enthalpy for the act of dissolving that, the solution process. So we've got to take this value over here. So our Q for our reaction, okay, the solution process, is the positive version of that number. So again, we're switching our signs. Heat lost equals heat gained, and vice versa. So if this was positive, this would be negative. Since this is negative, this is going to be positive. Okay, and then the last bit is just us cleaning up our work, converting our final units. This we need to convert to kilojoules. So we can put it up here, and then we're going to divide by our moles. So when we get our delta H for our solution process, we should have our kilojoules, which is positive, 2.626712 kilojoules all over our moles that we originally got. Okay, so we're getting about a positive 102 kilojoules per mole. So again, that positive is telling us that this process is endothermic. Alrighty. So you've got one more of those to practice at home, the one on the previous page right here. Make sure that you can do that, right? You got to be practicing every day. That's super important. And then our next video, we will work on Hess's Law, which is a fun little puzzle. Talk to you guys soon. Bye.